Hello friends, let's take up the modes of skeletal muscle contraction. This topic has got a very interesting applications when it comes to doing exercises, when it comes to getting into an athletic events, sporting activity. The way we train ourselves with different kinds of exercises has got a different levels of impact and different kinds of impact on our system. The way with which we train our muscles is going to play a significant key role in that, doctors. So what exactly is a muscle contraction and how this contraction pattern differs? What is isotonic? What is isometric? These are all the discussion that we are going to take up in this topic. So guys, before we get into the actual dynamics of muscle contraction and the variations in muscle contractions, isotonic, isometric, I want you to be familiar and aware of certain key terminologies. Although they make a very easy kind of meaning at a very superficial level, the depths of the meaning little bit differs, guys. So you exactly need to know what is contraction at the outset, what it exactly means, and what is a tone, what is isotonic, or what is a tone and all. So guys, I'll begin with addressing the word contraction. We'll understand what is contraction first, and then we'll go and discuss the tone, and then we'll go into the contraction, the different types and everything, guys. So at the outset, when it comes to the word contraction, please understand the word contraction doesn't mean shortening of muscles. This has got nothing to do with shortening of a muscle, guys. The word contraction refers to increase in muscle tone. Increase in muscle tone. Alright, I repeat, if you say a muscle is getting contracted, it doesn't mean the muscle is shortening. It doesn't mean that way. Then what does it mean? It means the tone of the muscle is getting increased. That is all. So to understand this in a clear manner, you need to know what is tone of a muscle. When it comes to tone, guys, please understand, every muscle who has got its own sarcomeres, and these sarcomeres are always in a state of partial contraction, right? So there is going to be a constant interaction between thick filament and thin filament, irrespective of the whole muscle going for shortening or lengthening, it doesn't matter. In every living muscle, there is always an interaction happening between thick and thin filament, and that interaction is going to create an element of bonding, an element of shortening of thick and thin filament, guys. So a whole sarcomere, if you consider, this sarcomere is going to be brought into an element of shortening. So that shortening of sarcomere, because of thick and thin filament interaction, is going to make the muscle cell to be in a state of partial contraction. And if you try to pull that muscle cell, since it is in a state of contraction already, in a minimal state of contraction, which means nothing but overlapping of thick and thin filament, that state is going to resist when you try to pull it across. So the resistance offered by a skeletal muscle cell when you try to passively stretch it is going to be called as tone. So let's get to see each and every words. At the outset, the tone is nothing but resistance offered. Resistance offered by a skeletal muscle. It can be a skeletal muscle or it can be a skeletal muscle cell when the cell is when it's been passively stretched. When it's been passively stretched. And this is what is called as tone, guys. Alright, this is called as tone of a muscle. Alright. Now, this is what is called as tone of a muscle. Now, why there is a resistance if it is getting passively stretched? The reason for this resistance is because there is going to be a constant overlap of thick filament which is made of myosin. Guys, you know this very well. You have studied the steps in skeletal muscle contraction, you know the structure of a skeletal muscle, you are already familiar with all these basic topics, and hence let me just take you into the concept here. So there is going to be constant overlap of thick and thin filament, and that is nothing but myosin as well as thin filament, guys, which is made of 3 proteins. Even though they are made of 3 proteins, the interaction is going to be made between myosin and actin. Alright, so this interaction between thick and thin filament is going to be called as muscle contraction, and this is practically makes the sarcomere to get shortened. Alright people, so shortening of sarcomere because of thick and thin filament interaction, that makes the tone of a muscle to be increased, and this is exactly what is called as contraction, people. So at the very fundamental level, when you speak about the word contraction, it boils down to just one point, where you are going to observe sarcomere that is going to get shortened. A sarcomere is going to get shortened. That is the very fundamental point. And what makes a sarcomere to get shortened? There is going to be overlapping, and there is going to be cross bridge formation of thick filament and thin filament, and that is going to make the sarcomere to be in a shortened state, and that is going to be the state of a muscle. When you try to pull it off, when you try to stretch it off, that is going to offer a resistance, which is colloquially called as tone of a muscle, guys. Have this very basic idea in your mind before we get into the skeletal muscle contraction, people. So with this basics, let's move on to see how does a skeletal muscle is arranged, and what is the steps involved in contraction of the skeletal muscle, and how that is being translated into a isometric contraction or isotonic contraction and everything. So people, let me take you into the concept of something called as load. So what do you mean by load? Load is something that